The focus of this video is mainly going to be over parallel and perpendicular lines. So how do we determine if two lines are parallel, perpendicular, neither? How do we write equations when we're told, when we're either given a point and told it's parallel or perpendicular to a given line? And then focusing a little bit on some average rate of change. So first off, when we talk about parallel and perpendicular lines, so these are two, think of it as kind of like special case situations that we want to be aware about sometimes because there are special relationships that are built from this. So parallel lines run perfectly side by side with each other. They might look something like this. Parallel lines have the same slope, different y-intercepts. Perpendicular lines, you kind of want to think about those as a four-way stop sign. So if you're at an intersection, two lines that intersect and form perfect 90-degree angles at all four angles right over here are perpendicular lines. So this is a visual of what that would look like. Perpendicular lines' slope multiplies to -1. Right? So if two lines have the same slope, they're parallel. If you take two lines and multiply their slopes together and get -1 when you do so, those lines are perpendicular to each other. If they're not the same, if you get anything other than -1 when you multiply, that is your neither case. That's going to be almost everything else where those two lines kind of just randomly intersect at a given point here. They're not parallel, they're not perpendicular, they're just two intersecting lines. So in order to determine if two lines are parallel, perpendicular, or neither, going back again to our definitions, they either have the same slope or their slope is going to multiply to -1. So what I'm hearing from that is notice that both definitions deal with the slope, right? They're either the same or they multiply to -1. So in order to determine if two lines are parallel, perpendicular, or neither, you must know the slope of both of the lines so that you can then figure out, well, hey, are they the same? Or if I multiply these two slopes together, do I get -1? But I need to know the slopes first. Starting with this first example, we are given these two equations, and we need to figure out the slope of these two equations so we can then answer the question. The easiest way I feel to figure out the slope when you are given an equation is to put that equation in slope-intercept form. Right? This is slope-intercept form right over here. Our equation needs to be solved for y. And as long as our equation is solved for y, m, our coefficient of x, is the slope of our line. So in a nutshell, solve your equations for y so that we can pick out the slope and compare to the definitions. So I'm going to go ahead and just rewrite these two equations and just drop them down so that we can solve each one of these equations for y, figure out their slope. Our left equation here, all we need to do is subtract 3x on either side. That 3x minus 3x is going to cancel. Dropping down that y is equal to -3x plus 4. Again, proper form, put your x term first, your plus or minus number behind it. So this equation, y equals to -3x plus 4. This tells me that my slope here is a -3. Again, once you have it solved for y, you're just looking for the coefficient of x. That represents your slope. So the slope of this line is a -3. Solve the other equation for y. To get y by itself, this is 3 times y. So do the opposite and divide everything by 3. 3 over 3 cancels, and we drop down y is equal to. Keep in mind there's a 1 understood to be in front of that x, so this is actually a 1 over 3x minus 6 divided by 3 is a 2. Look at your coefficient of x, and that tells me that my slope is a positive 1/3. Now it's just a matter of a comparing game. So going back up to our definitions, they're parallel if the slope is the same, and they need to be exactly the same numbers, same signs. Now, -3 is not the same thing as a 1/3. These are obviously not the same numbers, so they are not parallel. In order to figure out if they're perpendicular, the next thing we need to do is multiply the slopes together. So take -3 times 1/3, multiply that. You can throw that in your calculator if you really want to. This is just multiplying fractions. Put that -3 over a 1 and multiply across. Top times top, -3 times 1 is a -3. Over bottom times bottom, 1 times 3 is 3. When you divide this out, well, 3 divided by 3 is a 1. So we are left with a negative 1 when we reduce this fraction. And we do get a negative 1 when we multiply. So that's the exact definition of perpendicular lines. Perpendicular lines as slopes multiplies to a negative 1. So for this first example here, this is a perpendicular case. We know that because we saw for slope, we multiplied them together, and we got that negative 1 that definition says. So let's do our next example, and let's see what we're looking at here, right? Two different lines. All right, let's break these apart. All right, a lot of times they always give you the two equations stacked on top of each other. So the first thing I do is separate them, move them side by side so that I can solve them for y. Now the first equation is already solved for y. So that means the slope here is that positive 3 that we see. So we only need to solve this second equation for y. Let's add that 2 to the other side, giving us 2y is equal to, well, drop down that 6x plus that 2. Divide out this 2 here, and when we do that, 2 over 2 cancels to y, over 6 over 2 is a 3x, plus 2 over 2 is a 1. That means the slope of this line is a 3. So going back up to your definitions, comparing here, parallel lines have the same slope. 3 is the same thing as 3. All right, they're both the number 3. They're both a positive 3. So we are looking at a parallel case here then. If they're the same, it's parallel. Multiply to negative 1, perpendicular. Anything else would be your neither case. Next example is we're going to focus on writing equations of lines here in point slope and slope intercept form. So we will create both equations of those lines. So just for reference here, we have our point slope equation, we have our slope intercept equation. So I always like to create point slope first and then take that equation and tweak it and turn it into the bottom equation here. So we will state the equation in both forms here. So first, let's take a look at example C. Example C tells us that we have the line passing through the point negative 3, 1, and that our line is parallel to this one here. So this is not the equation of our line. We are told our line goes through this point and is parallel to this equation here. Now, in order to write an equation of a line in point slope, we need the slope, and then we need a point, our x1, y1. We're given a point, so this negative 3, 1 will be our x1, y1. The only other thing we need to figure out in order to write our equation is what the slope is. And that's going to come from the second piece here. They're telling us that our line is parallel to this one. Going back up to definition of parallel lines have the same slope. So if our line is parallel to this, parallel lines have the same slope. So the slope of this equation is also the slope of my equation that I want to use. So we're going to say that our slope is 2, and it's going to go through this point. So let's go ahead and plug that into the point slope formula. That's going to look like y minus our y1, which is a 1, is equal to our slope, which we said is a 2, open parentheses, x minus our x1, which is a negative 3. Simplify this equation, and the only thing we need to simplify is this double negative rule. So this gives us y minus 1 is equal to 2 times, well, x plus 3, right? Those double negatives there cancel out to a plus. This is our equation in point slope. Plug in the point, plug in the slope, simplify. But we also need to build this equation in slope intercept form. That is what our instructions said. We're going to do both forms of the line. So I'm going to drop this equation down, and we're going to tweak this equation to turn it into slope intercept form. In order to do that, that is 2 steps. Move your number over here by the y. So whatever plus or minus number that is, move it over to the other side. So we are going to add 1 to the other side. Also, distribute the number in front of the parentheses. We want to distribute this too. When we do so, that gives us 2 times x, which is 2x, plus 2 times 3 is a 6. Don't forget that we moved this 1 over to the other side, so that needs to drop down here, so that when we simplify this equation, this is y is equal to 2x plus a 7 for our equation in slope intercept form, and then our equation for point slope right over here. Let's do the same exact thing here for example D though. We are told that we have that our line is going to go through the point 3, -5. So I'm going to automatically label that my x1, y1. We do know this point is on our line. And we're being told that our line is perpendicular to this one. So going back up to perpendicular definition, perpendicular lines of slope multiplies to -1. And we need to figure out how do we use that in order to figure out the slope that we need to use here, okay? So first, before I get into that, I'm just going to tell you, let's solve this equation for y so we know what the slope of this equation is. That's not going to be our exact equation, right? If we were told it was parallel, we would use the same slope, but it's perpendicular, and that's a little bit different here. So first, let's solve for y. So if we're going to solve for y, we need to move everything over to the other side of the equation. So I'm going to subtract that x on from both sides. I'm also going to go ahead and add the 8 to the other side. That way I can keep the 4y over here on the left. We're moving this x over, so now we have a minus x, and then we added that 8. To solve for y, all we need to do is divide by 4, and when we do so, we get y is equal to, again, keep in mind there's a 1 understood to be there, so this is a -1/4 x plus 2. That means the slope of this line is a -1/4. We don't want to use that exact slope. Our slope is perpendicular to this. Now, what that means here, if you notice in this example that we had previously, these two lines were perpendicular to each other. So let's take a look at what happened here in order to create that -1. If we look at the slope of the first and the second line here, they're very similar. Notice the difference between these two. If I took this 1/3 and flip that around, right, flip the fraction, that would now be a 3/1. 1 is positive, 1 is negative. So if I take a slope, flip it, and change the sign, that will give me the slope of the line perpendicular to it, right? And when we multiply those together, we get a -1. So we're going to use that concept to help us here. This slope is a -1/4. So what we need to do to create our slope, flip this fraction. Instead of 1/4, we want to use a 4/1. Change the sign. This was negative. We want ours to be positive. So the slope we are going to use is a +4. So that's what we're going to use here. That's what we're going to plug into the equation. Let's go ahead and plug that into point slope. Y minus y1, which is a -5, is equal to our slope, open parentheses, x minus x1. Simplify, and we get y plus 5 is equal to that 4 times x minus 3. That is our equation in point slope. Now we also need to write our equation in slope-intercept form. So drop down that equation, move the number over, distribute that 4. We're going to want to subtract that 5 to the other side because we want it y equals, and we're going to distribute that 4 to give us, well, 4 times x is 4x, minus 4 times 3 is 12. Drop down that minus 5 that we moved over. When you combine your like terms, we get y is equal to 4x minus 17 for our equation in slope-intercept form. Last thing in this video is going over the average rate of change. The average rate of change talks about the change in slope from one given point to another. Essentially, this is the slope formula. The slope formula is y2 minus y1 over x2 minus x1. If we compare, our denominators are definitely the same. Our numerators, this numerator is just in function notation. F of x2 is the same thing as y2. If you took x2 and plugged it into your function, that result would be your y2. If you took x1, plug it into your function, that would be your y1. So really the average rate of change is just the slope formula is all we're doing here. So we're being asked to find the average rate of change of this function between 3 and 6. So essentially, if we're talking about a coordinate system, we're just talking about what is the slope between 3 and 6. So if we were just looking at just this chunk in our graph, let's say that was our line, right? Between here and here, What is the slope of that section here, or the average slope between those 2 points there? So let's fill out this equation here. Now let's go ahead and do the denominator. That's the easiest part. Our denominator is x2 minus x1. Well, they told us that x2 is a 6, minus is part of the formula, x1 is a 3. Now in our numerator, we need to find f of x2. Now, f of x2, x2 is a 6. So they're asking us to find f of 6. Now, if I find f of 6 of this equation, I am plugging in 6 for x and simplifying. When we simplify, 6 squared is a 36, 2 times 6 is a 12, and when I add those together, I get a 48. So f of 6, which is f of x2, is 48. And we're going to take that and we're going to subtract it to f of x1. F of x1 is a 3, so now let's find f of 3. Plug it into the same equation. That's going to be 3 squared plus 2 times 3. 3 squared is a 9, 2 times 3 is a 6, and when we add those together, we get a 15. So f of 3, f of x1, is just a 15. So just double check that you did put everything correctly. This is our f of x2 minus our f of x1 over x2 minus x1. Subtract and simplify. 48 minus 15 is a 33. Over 6 minus 3 is a 3. And we can divide this out fully. 33 over 3 is an 11. So that would be your average rate of change, your average slope between 3 and 6 for that given equation. This was just a random example I drew just to kind of give you a visual. But between 3 and 6 for this graph, this is what our slope, our average rate of change would be.